Hi everyone, in this video we are going to discuss lipids, and we're going to use lipids as a way to introduce triglycerides, and we're going to use triglycerides as a way to introduce fats and oils. But in order for us to discuss fats and oils in the context of food and our human body and what happens when we ingest the fats and oils, we have to back all the way up and actually talk about lipids first. So we're going to start off by just getting a very, very simple definition of what a lipid is. So a classic definition of a lipid is just a class of fatty acids that are insoluble in water. Okay, so if we take these things and we put them in water, they are not going to dissolve. You would be able to see them. In the same way that if you put a rock in water, usually it would just stay right there and not dissolve, right? Lipid is the exact same thing. So now, more importantly, a class of lipids are called triglycerides. So triglycerides. Okay, make sure you can spell that. Triglycerides. Now, triglycerides are molecules that contain 3 ester groups. Okay, 3. It is very specific. It must have 3. We're calling them triglycerides. You have to have 3 ester groups. Now, when I say group, I'm talking about something in chemistry that we have given a word to, okay? So these are called functional groups. So an alcohol or carboxylic acid, any of these terms, or even an ester, these are all called functional groups. So an ester is going to be the first one we introduce. So you've seen something similar to this before. So it's a carbon that is a double bond with an oxygen. That carbon is also attached to a regular old oxygen. And then this oxygen is attached to a carbon. Okay, this is the main piece or the main components that make up an ester. So you have a carbon with a double bond to an oxygen. It is also having a single bond to an oxygen. That oxygen is also singly bonded to a carbon. Now, we're also going to introduce this term R. So whenever you see R in chemistry, especially organic chemistry or any drawing like this, it just means generic stuff. So it's just saying more chemistry is happening here, but it's not important. So we're going to start using R's to kind of show you the differences and everything here and use it as a way to indicate generic chemistry. So what I have drawn here is called an ester. So your ester is the C double bond O with an oxygen connected to another carbon. That is an ester. Now, a triglyceride is made of 3 fatty acids plus a glycerol. Okay, so let's write this out. So 3 fatty acids plus 1 glycerol is going to give you 1 triglyceride, and then it creates 3 waters. Okay, I do expect you to know this, so make sure you commit that to memory. Now, let's start off by talking about a glycerol. So glycerol is a very, very unique molecule. It's very simple. You have a carbon that's attached to another carbon, which is attached to another carbon. Now, each of these carbons have what are called an alcohol attached to it, so an OH. Anytime you see an OH like that, that is called an alcohol. Okay, so now we also know that carbon likes to have 4 things attached to it, or it likes to have 8 valence electrons. So in order to balance this, we need to make sure that we have all of our extra hydrogens on here. So it looks a little sloppy. A lot of time people just draw out glycerol like this, and then you just draw your OH groups on there or your alcohols on there. Okay, so a lot of times if you ever see that, we're indicating just a glycerol. So now we've introduced the term ester. We've also introduced an alcohol. So an alcohol is your R OH, okay? So now that's a glycerol. So now a glycerol has to be bonded to 3 fatty acids. Well, I keep saying fatty acids, but I don't expect you to know what that is, so let's give a definition. So a fatty acid is a molecule with a long hydrocarbon chain. So hydrocarbon chain, meaning it's only comprised of carbon and hydrogen. Okay, so a long, long hydrocarbon chain that ends in a, here's our third group we're going to talk about, a carboxylic acid. Okay, so here's our third group. So let's identify a carboxylic acid first. So we've got R, so generic chemistry, attached to a carbon. This is the important part. Carbon doubly bonded to an oxygen, single bond to an oxygen. that oxygen is attached to a hydrogen. So a carboxylic acid and an ester should appear very, very similar. The only difference is in a carboxylic acid, you have this OH component. In an ester, it's OC, okay, an O attached to a carbon. They're very different, but they do look similar, so you have to get them separate. All right, 3 fatty acids plus a glycerol create 1 triglyceride plus 3 waters. Don't forget that. All right, so now let's investigate these fatty acids. So these fatty acids have a long, long hydrocarbon chain. All of this is your long hydrocarbon chain, and then bam, right there you have your carboxylic acid. So this is it written out with all the atoms, your carbons, your hydrogens. We also have your line drawing right here, so you can see what it would look like. So you have your long hydrocarbons, and then you end in your carboxylic acid. And then here's the ball and stick model, just so you can kind of have an idea of what it looks like in space. It is a long structure, but it kind of looks like a tube when it all packs in together. And then you see the red situations, or the red spheres over here. That's indicating oxygen atoms. All right, so now let's bring this all back together. 3 fatty acids plus 1 glycerol creates 1 triglyceride plus 3 waters. Okay, so now this is a reaction I expect you to know. You absolutely have to know this. So now what I want you to do is visualize this as we see the synthesis, if we put this all together. So this is really small, so hopefully you can see it. Let me see if I can enlarge it just a little bit. It gets really blurry. On the left, 3 fatty acids. So we have 3 right here. Fatty acids. So here's your long hydrocarbon chain. Here's your carboxylic acid. Plus 1 glycerol. This is just 1 glycerol. Then over here we have a product. This is our triglyceride. And then as we always see, we have 3 waters. So what I want you to focus on right now is your carboxylic acid and your alcohol. So let me kind of try to highlight these for you. So here I see our carboxylic acid. We have 3 of these in our fatty acids. These are going to combine with 1 of our alcohols in the glycerol. So this is going to go to 1. So remember, there's 3 of them. So 1's going to interact with that one. 1 carboxylic acid is going to interact with this one, and 1 carboxylic acid is going to interact with this alcohol group. So 3 different components. So they each come in, and so then the red part here in the triglyceride over here, this is the new piece. So what we've now created is we've taken something that was COOH and we've changed it to create an ester. So we have CO and then this O. Now we see this carbon, this new carbon that wasn't there before. Same thing here. You have your COO and now you've attached it to another carbon. Same thing here, COOO. So now we've got 3 esters. So this last component is a triglyceride because it has 3 ester pieces. And then obviously we always release 3 waters. Now where do the waters come from? We have an OH here in our glycerol, or our alcohol component. The OH, we react it with our carboxylic acid, the COOH. So the H and the OH come together to create your water, and then you end up having your COO come in with the original carbon on your glycerol, and then you are able to actually create that triglyceride. Now, I know that that was unbelievably overwhelming and a lot, so please take your time and rewrite this out and make sure that makes sense to you, because it's super important to me that you can see how these things kind of click together. It's basically just a little puzzle for nerds, okay? All right, some questions here. I want to know some names. What is the name of this functional group? What is the name of this functional group? And what is the name of this functional group? So it's going to be a carbon with a double bond to an oxygen, and then an O, and then another carbon, then R. Okay, so 3 pieces here. Go. All right, did you get an answer? Hopefully you did. This is very, very, very important. So please make sure you just put these on flashcards right now and memorize these, because I'm going to refer to these as their names, these functional group names from here on out. So anytime you see an OH group, you now know that is an alcohol, or what chemists refer to it as an alcohol. If you see COOH, you know that is a carboxylic acid. COOH. And then the last one here, COOC, instead of a carboxylic acid, we actually have an ester here, okay? So we have an alcohol, a carboxylic acid, and an ester. Now, what we're going to do to finish this video is come up with a quick flow chart so that you can start mapping out fats and oils in your head. So the first thing you need to realize is that you have lipids. Remember, lipids are your fatty acids that are not soluble in water. We can break this apart to triglycerides. Triglycerides, we remember, are lipids that have 3 ester groups, 3, tri. Now what we're going to do in the next video is we're going to break this apart into fats and oils. So at room temperature, our oils are going to be liquids. At room temperature, our fats are going to be solids. Okay, so that is the big picture. That's where we're going because we eat fats and we eat oils and we need to know what happens. All right, take care of yourself and eat lots of veggies.